Greetings everyone, I hope you're doing well. So today we are going to discuss about the application of Kc. Kc is the equilibrium constant which is used to determine the several aspects present within the reaction, whether the rate of reaction, it's not associated with rate of reaction, but actually we are discussing about the extent of the reaction. Application of Kc. Why is equilibrium constant utilized? Why is it calculated? What's the need of this? Basically, there are several purposes for application of Kc's. Application of Kc's first is utilized to determine the direction of the reaction, that in which direction is the reaction going, whether it is going in the forward direction on the right side, or it is going in the backward direction on the left side, or even if it does not has any direction, we are going to conclude that it is an equilibrium reaction. Now this is the first part in which we are going to know how to determine the direction with the help of Kc. Second part includes the extent of reaction. What does extent mean? Extent means the extent of reaction. Extent here is defined as the longevity of the reaction, that whether the reaction is supposed to continue, whether it will be continued, whether it will be further undergone in the process in order to complete itself, whether it will go towards the completion, whether it is completed already or it will never go to completion. That is the extent of reaction which will be talked and discussed in the applications of Kc's. First, let us discuss about the extent of reaction. Extent of reaction here is determined by the value of Kc. If Kc is having a value which is very small value of Kc which is less than 10s power minus 3, if the value of Kc is less than 10s power minus 3, then we can say that the concentration of reactants is more than the concentration of products. If value of Kc is less than concentration of reactants is more than the concentration of products, which means the stability of reactants is more than the stability of products. As a result of which, the reaction favors a backward reaction, which means it says that the reaction is virtually incomplete. As it is a virtually incomplete reaction, it is supposed to go in the backward direction. Hence there are more chances, more tendency of the occurrence of the backward reaction as compared to the forward reaction. Also forward reaction can also occur, but there will be less tendency. Moreover, uh, examples of it are given, such as decomposition of water at 500 Kelvin, at which the rate of reaction is 4.1 into 10 power minus 48, which is very small, as a result of which it favors the backward reaction, reverse reaction, as the concentration as the reaction told here is virtually incomplete. Likewise, if you are having a value of Kc too large, greater than 10 s power 3, then concentration of product will be greater than concentration of reactants, stability of products will be greater than stability of reactants. As a result of this, the reaction which would be occurring would have more of the products, due to which the reaction would be virtually completed. As it would be virtually completed, forward reaction will occur, and tendency of backward reaction will be less as compared to forward reaction. So in this case, the examples of it are given as HCl having hydrogen and chlorine, um, forming HCl at 300 Kelvin. 4 into 10 to the power 31 is the uh, value of Kc, while another example of oxidation of carbon monoxide, in which the equilibrium constant is 2.2 into 10 to the power 22. Likewise, if we are having Kc value neither too large nor too small, or between 10 to the power minus 3 and 10 to the power 3, then the concentration of reactants and products both become nearly same, become constant. As the concentration of reactants and products become constant, then both the forward and backward reactions are occurring, which means neither the forward reaction will go to completion nor the reverse reaction will go to completion. As a result of both reaction not going to completion, it will be concluded that the reaction never goes to completion. Examples of this include dissociation of bromine monochloride at 1000 Kelvin. 2 bromine monochloride, it decomposes, dissociates into bromine and chlorine. So here the value of Kc is 5, which means that here the equilibrium constant is neither too large nor very small, as a result of which this will be concluded that the rate of reaction is at equilibrium. Equilibrium is established. Now, similarly, formation of hydrogen iodide at 700 Kelvin showcases that here the value of Kc is 57, which means again it will not go to completion, and it cannot be a useful process because increased value of Kc, because a prolonged time period in which the equilibrium is maintained can lead to some industrial uh, problems, industrial crisis, which we are going to discuss in some of our next videos as well. So that's all about this video. Hopefully, we'll meet again in another one.